Hey guys, welcome to a new video. In today's video, we're going to look at this GeeksForGeeks question, merge to sorted linked list in reverse order. So in this question, we are given two linked lists of size n and m. The task is to merge them such that the resulting list is in non-increasing order. So we are given two lists which are in ascending order, non-decreasing, and our task is to merge the two lists and then reverse them so that the final single list is in decreasing order. So here in this case, 1, 3 and 2, 4 are the two lists. So if you merge them, you get 1, 2, 3, 4 in ascending order, that is non-decreasing. And after that, we have to reverse that list. So 4, 3, 2, 1 will be your output. Now let's take this example and see how we can solve this question. So these are the two lists given to us. So first we are going to start by creating a dummy node. So I create a dummy node and initialize the value -1 to it. So this current is also a node which will point to the next element. So here you see both these lists are sorted in ascending order. So first I'm going to pick the two elements at the beginning of both the lists, check whichever is the smallest. So I pick 5 and 2. Since 2 is smallest, I connect the current node to this. So current.next is pointing to list 2. Since we picked this inside list 2, we have to pick the next element by moving list 2 here. So list 2 is now moved here. And list 1 is still as this because we haven't processed this element yet and we have to consider it for our next comparison. So current which was here will be at the last processed element so that it can point to the next node. Now we pick the element at list 1, 5 and we pick the element 3. We check which one is less. 3 is the minimum among it. So current will point to 3. We process this element inside list 2. List 2 moves forward to point to the next node inside that and list 1 is still here because we haven't processed that element yet. And now current moves to where the last processed node was there. So current is moving here. Now we process the elements at list 1, 5 and list 2 element is 20. Which one is minimum? 5 is minimum. So current will point to that element. So current is here. It will go and point to this node. And we move list 1. List 1 is now here because we process this node inside list 1 and current will move to that. So current is also now here. Now we compare the elements at list 1 and list 2. Again we pick 10 which is list 1. So current will point to that and since we process this, list 1 will move forward and current will move to the last processed element. So current is now here. Now pick the nodes at list 1 and list 2. List 1 node is 15 and list 2 node is 20. Pick the minimum among them. It's list 1, so current will point to that node. And since we process this element, move list 1 forward and current will move to the last processed element which is 15 so that it can point to the next node. Now pick the nodes at list 1 and list 2. List 1 node is 40, list 2 node is 20. Minimum among them is 20, so current will point to that element. And since we process this element, list 2 will move forward and current will come to the last processed element which is 20. Since list 2 is pointing to null, we end our iteration because this iteration will happen until list 1 and list 2 are not null. Since list 2 is null, there are no more elements to be processed and our answer will come from list 1. So you can directly point current to the next elements present inside list 1. So in this example, there is only one node. If there are many nodes in list 1, all those elements will be the last part of the answer. And this is the dummy node, right? So we return dummy.next. Dummy is pointing to this, so this is dummy.next. So we start our answer from here, so that is the new head. So let's form our answer. The first node is 2. 2 is pointing to 3. 3 is pointing to 5. 5 is pointing to 10. 10 is pointing to 15. 15 is pointing to 20, 20 is pointing to 40 and 40 is pointing to null. So this is our merged list which is in ascending order. So we return dummy.next. So dummy.next will start from here. So this is our ascending order list. Now this is the first part of the question. We merge the two lists given to us into one single list and now the one single list is in ascending order. Now we have to do the second part of the question, that is reverse this one list. So if we reverse the final list, we will make from ascending to descending order, which is the required output. Now we have to reverse this list. So this is the head of the linked list. Point a node called current to the head of the linked list. I create a node called next pointing to current.next and I create previous is pointing to null. Now the iterations will happen until current is not equal to null. So until current reaches from beginning to end will keep on iterating. In each step, in each iteration, first we have to do this step. So current.next is the pointer. It is pointing to previous. So current.next will point to previous. Previous is at null. Previous comes to current, and current moves to next, and next moves to current.next. Now we repeat the process. Current.next is pointing to previous. Previous is pointing to current. Current is pointing to next, and next is pointing to current.next. Now repeat. Current.next points to previous. Previous points to current. Current points to next, and next points to current.next. Now repeat the process. Current.next points to previous. Previous points to current. Current points to next, and next moves to current.next. Current.next points to previous. Previous moves to current. Current moves to next, and next moves to current.next. Let's repeat. Current.next points to previous. Previous moves to current. Current moves to next. Current.next is null, so next won't be moved. Current.next points to previous. Previous moves to current. Next was here, and current will move to next. And now as current is pointing here, this condition will fail because current is pointing to null. So we move the head which was in the beginning. So head will move to where previous is pointing. So head is pointing here, and we can return head. So let's form the output starting from head. Head is pointing at 40. 40 is pointing to 20. 20 is pointing to 15. 15 is pointing to 10. 10 is pointing to 5. 5 is pointing to 3. 3 is pointing to 2. And 2 is pointing to null. So we finished the second part of this by reversing the linked list, and this is the expected output. So these are the two steps which we need to follow. First we need to merge the two lists into one. We'll get a single list which is sorted in ascending. And now we have to reverse the linked list to make ascending to descending list. Now let's implement this in a Java program. First I'm implementing the merge to list function and storing the single list in the merged list, and then I'm implementing the reverse list function for which I'm passing the single list which is in ascending order. So this will make the whole list in descending order. First let's look at the first step. To merge two lists, we are given two lists, list 1 and list 2. We create the node -1, dummy node, and place the current node to dummy. So this while loop will happen until list 1 and list 2 are not equal to null. So if list1.data, so we are comparing the values at list 1 and list 2. So we are comparing these two values. Which one is less? If list 1 value is less than list 2, then current will point to that element and we move list 1 to next. Else, which is the opposite of this, if list2.data is less than list1.data, then this will happen. We point current to list 2 and move list 2 to the next node. And we move current to current.next. So .next is the pointer, and this while loop will happen until this condition is satisfied. Once this condition fails, it comes out of the while loop. So if list 1 is not equal to null. So this is talking about this case where list 2 pointed to null first and there are no more elements inside list 2. Then we point the last node inside list 2 to list 1. If list 1 is not equal to null, which means list 2 pointed to null, then we move current.next to list 1. Like in this case, we moved current.next to list 1. And if the opposite happens, we move current.next to list 2. And finally, we return dummy.next. Initially, we created this dummy node, right? So we return dummy.next, which points to this node. And I'm calling this function inside the main method here and storing it inside a single merged list. So this merged list is a node which is pointing at the head. So we have this list after the first function call. Now I'm passing this head to this reverse list function. So I'm pointing the three nodes. Previous points to null, current points to head, and next points to current.next. And this will happen until current is not pointing to null, which means until current reaches from starting to end. And in each step we have to point current.next to previous. Previous will move to current and current will move to next. And next will move to current.next only if next is not equal to null. Because here in the beginning, next is one node ahead to current. So current was here and next is here. So this while loop will run until current is not equal to null. So in the last iteration, current will be here and next is already pointing to null. So we have to place this extra if statement that next is not equal to null, only then next is equal to current.next. And once current reaches null, we have to move the head which was initially at the beginning to where previous is pointing here, so that we return the head from end 40, 20, 15, 10, 5, 3 and 2. So this will be our final output. So linked list is all about moving the pointers, that is the next pointer, to the next node. And this reverse list function will be the second function, and this will return our output. And this is an important check. If you don't place this check, if n is 0 and m is 0, there won't be any nodes to check, so we directly return null. So this check is important as a base check. Now let's run the code. The test cases are running. Let's submit the code. And our solution has been accepted. So the time complexity of this approach is O of n because we are iterating through the linked list from starting to end. And the space complexity is constant because we are not using any extra space to solve this question. That's it guys. Thank you for watching and I'll see you in the next video.